Sometimes when you're benchmarking, you get a somewhat unexpected result. For example, in this test here at 1440p Ultra, we're seeing the 4060 beating the 7600 by about 31%, which is unusual. These GPUs are usually within about 10% of performance, plus or minus, depending on the game. Sometimes it favors one or the other, but usually a 30% performance gap seems, out of the ordinary. So you start to wonder, why is this happening? And so when I compare this result to something I saw in the last video I was doing testing this same game on GPUs with different VRAM amounts, this actually, I think, follows up with some comments that I saw, and I've seen on other videos kind of pointing this out, which is, does AMD actually use more VRAM in the same situation than Nvidia does? And so where would we be looking to kind of look for this information? So in this particular test we're looking at, this is the 4060 Ti 8GB and 16GB models, as well as AMD's RX 7700 XT. Now this is interesting because the 8GB and the 16GB card are basically the same GPU. When they are not limited by VRAM issues, they should have basically identical performance, other than the fact that they're slightly different GPU coolers, slightly different boost clocks, but they're within 1 or 2% performance of each other when there's no issue with 8GB of VRAM. Now, in this particular test, with the 7700 XT as comparison, it's a 12GB card, so unless we're going over 12GB, we won't see performance issues on the AMD side of things. But in the review I was working on next, we're looking at two 8GB cards, the 4060, which is 8GB from Nvidia, and the RX 7600, 8GB from AMD. Now, if I pop back over to this other one, where we have the 8GB, 16GB, and 12GB cards, I've noticed some comments, and I've noticed this myself, where if you look at the line of memory, the GPU memory, so this green mem line, this one is what's being reported to my software. I'm using MSI Afterburner with the Riva Tuner Statistics server here. And so, one thing you have to be beware of is, are things just reporting differently, from the brands, that kind of thing. But let's just get into the weeds here a little bit. So what is this actually trying to report? That is the GPU's reported total VRAM usage. The next number over is its reported per process usage. This is total allocation, sorry. So total allocation for the GPU, this is per process usage. So I understand that as what it's reporting to the software as this particular application, this particular game is trying to use. And all of the GPUs have those stats here, right? Now, what you might notice is a GPU that only has 8GB of VRAM can't report over 8GB of VRAM. It's just not there. And then the GPU that has more than 8GB of VRAM can report an allocation, a total VRAM allocation on the system going over 8GB. And notice that in this case, we are seeing a fairly noticeable performance difference between the 8GB and the 16GB GPU. Because the 8GB card, to run this same exact scene on exactly the same GPU, is looking like it's having to access system memory. This RAM line here is the system RAM. And so it's looking like it's having to access system memory, which is slower than accessing VRAM, and that slows down its performance in the game. And that's what we're seeing here. But if we look over at the AMD line, notice that it's reporting almost 10GB of VRAM allocation and about 8GB of per process usage. Notice it's running exactly the same scene and exactly the same game at exactly the same settings, but it is reporting higher VRAM numbers there for both the total system allocation and the per process usage. Now, I'm curious about that, especially because of how what I'm seeing running these two 8GB GPUs, one from Nvidia and one from AMD, in exactly the same game. Because what I'm noticing here, with the 4060 being 31% faster, again, is that's an unusual result, but it feels like, and if we move forward in this testing here, it feels like this could be VRAM related, despite the fact that they're both on 8 gigabytes of VRAM. So if we move forward to where I test out the high preset, notice that when we drop down to the high preset, not only does just performance go up by a lot for both GPUs, but it's now much more close together. We're seeing 54 FPS versus 50, which is an 8% lead for the 4060. So this still looks like one of the games where the 4060 is more favored, but again, it's a less than 10% margin. It's not that blowout like we saw at those at the ultra settings at 1440p. So that's interesting, right? Now, if we go over to the sorry, that's my voice in the background here. If we go over to the 8 gigabyte versus 16 gigabyte situation that we had over here, then we have some more evidence we can look at, where if we drop down to the high settings, let's see, where did I test that out? Here we go, 1440p high. You can see that the 8 gigabyte and 16 gigabyte GPUs at these settings perform identically. And if we look at it, even on the GPU that has it, we're not seeing any memory being reported above 8 gigabytes. If we check the AMD side of things, again, the reported VRAM total allocation and per process usage are higher than what we're seeing on the Nvidia GPUs, but they're also under 8 gigabytes, right, in exactly the same scene. So, in other words, this seems like an issue where what we're seeing on the 4060 and the 7600, which are both 8 gigabyte cards, right, is that at 1440p high, they're both under their 8 gigabyte limit, and so they're performing more like you would expect. This just seems to be a game where the 4060 is probably favored by about 8%. And then, like I said, when we go back to those ultra settings, to explain that 31% performance advantage for the 4060, again, it seems like that could be a VRAM-related issue, especially when, again, we look back to how that compared to our stats on our other cards. Now, that seems weird at first, right? Like, shouldn't the game just need a certain amount of VRAM to operate regardless of the GPU brand, right? Now, this is where we get, in other words, like, so where's my area of expertise on all this? So to be clear, I'm not, a GPU engineer. I don't know how these are designed. I don't know the nitty-gritty details of how the GPU driver interacts with the system and how games use all of that. Like, I focus on just like, I can test GPUs, I can notice things happening, I can measure their performance. But when it gets into why would that be happening, it's really more of a speculation point. And it's also possible that something else is happening here, right? Something else about the ultra settings, just not liking the 7600 in this case. I mean, I think that's possible. But I really do think that given what we're seeing on the 8 gigabyte versus 16 gigabyte versus 12 gigabyte cards here, I really do think that this is likely the case. It feels very VRAM related, especially looks like it when we're looking at these numbers on these GPUs, right? But then why would AMD be using more, right? So this is where I want to be clear that I'm just kind of speculating here. So one thing I was considering is, well, I do have smart access memory enabled on all my testing. I have that on by default. I'm on an AM5 CPU system that just enables that by default, so I'm very out-of-the-box settings. That is enabled by default on these systems. So smart access memory is on, but AMD and Nvidia do handle that differently, where Nvidia, if you turn ResizeBAR support on your PC, NVIDIA has a whitelist of games where that's enabled, so I'm curious if the amount of VRAM being used or being trying to be used here could be being impacted by ResizeBAR or AMD Smart Access Memory, and that would take additional testing. I'm actually curious in these situations if I ran Smart Access Memory off, if we would see a difference in VRAM usage. So I'm just spitballing possible further things for testing that I don't have time in this video, but maybe would be something interesting to look at in the future. So one difference between AMD and Nvidia is how they handle ResizeBAR, right? If the game is not specifically whitelisted by Nvidia, the game won't try to use ResizeBAR. unless you force it yourself through third-party software. So maybe that explains the difference. But what else could explain the differences? Other things I thought of is just, these GPUs use different drivers. So the GPU interacts with the software in some way, and there's software levels like between the GPU hardware and the game software, and so perhaps they schedule the usage of VRAM differently. And maybe AMD is somehow more aggressive on how much it's trying to use. Maybe there's differences in any sort of, I don't know if some sort of compression happens in there. But it certainly seems like it's the case. And if we scroll through just some other benchmarks now here, if we just pick any kind of random screen, like here's Lords of the Fallen. Again, this is looking at the 8GB, 16GB, and 12GB AMD cards. If you just look at the memory line, it does seem to consistently be the case that AMD is reporting higher usage and higher total allocation. If we just scroll through here, like you pick any random I'm just going to randomly pick something here. The Nvidia GPUs here seem to be reporting, under 6 on total allocation. This is over 6 on total allocation. 4, 5, right, for per process usage. So again, this seems to be a consistently reported thing when we look at running the same scene on these GPUs. And then again, that question kind of comes down to, so does it, is it just a reported amount, but then it doesn't really matter if you go over that amount? Could it still function on that lesser amount? But then, so that's where I kind of want to go back to our 8GB cards and check if we see any other performance differences in these kinds of places, right? Because there are definitely cases where the Nvidia GPUs seem to be just under that 8GB amount, whereas that slight increase in VRAM allocation seems to put our 12GB AMD GPU to allocate at least a little bit more than 8GB of VRAM, which again, on the 12GB card doesn't cause any kind of performance discrepancy. But in the same scene, there doesn't seem to be much difference between the 8GB and 16GB Nvidia GPUs, right? So anyway, let's go ahead and look through some more of these 8GB cards up against each other. Because again, when we drop down to the high settings, and the VRAM comes more under control, we saw them perform more closely. Let's go ahead and jump around here. So again, still using the ultra settings, but with upscaling, it seems like we're still seeing a larger than expected performance gap between the two. But again, this is a situation where I think the AMD card is pushing up against its VRAM barrier. I think that explains that result. We're even seeing this at 1080p Ultra. And 1080p Ultra, let's go back to our GPUs that had more VRAM, and let's try to find that same setting. So at 1080p Ultra, interestingly, we actually do see a bit of so the AMD GPU that has more than 8GB of VRAM is reporting over 8GB of VRAM allocation. So it does look like 1080p Ultra in this game is going over 8GB on AMD, and it's actually going a little bit over it on Nvidia as well, just it doesn't seem like as much, right? So you're seeing only like a 4% gap between the 8GB and 16GB Nvidia GPUs. But again, when we hop back here to the 4060 and the 7600, we're seeing a 20% performance gap between these. And remember, when it seemed like there was no VRAM issue, it was an 8% performance gap. So it's looking like even at 1080p Ultra, again, it seems like it's explainable by the VRAM thing, because when we then drop down to the high settings, the 4060 only takes a 5% performance lead at the high settings in this game, which seems to be bringing down our VRAM usage quite a bit. And again, if we pop back over to the cards that I had in my other video with the larger VRAM amounts, if we drop down to the high settings, again, these are showing that even cards that have more than 8GB of VRAM are not attempting to allocate it. So interesting stuff, right? So let's go ahead and just kind of keep moving through some results here. Let's go to RoboCop, right? So RoboCop Rogue City 1440p Ultra, my 8GB cards are showing a 12% performance advantage for the 4060. And you can see the AMD GPU trying to allocate right up to that full 8GB limit, but are we then spilling over into system memory and slowing down? So if we pop back over to our set of cards that had more than 8GB of VRAM, let me find where I was testing RoboCop in this one. Okay, RoboCop 1440p Ultra. On an AMD GPU, let's go ahead and see where we are at here. It's looking like we are allocating more than the 8 gigabytes of VRAM that we saw here. Sorry, something messed up in my OBS recording. Just a second here, guys. I can't. Why can I not move my face around? I always move my face around. You guys might have to get by without me moving my face around. I might have to point at things like a normal person with my mouse pointer. Anyway, so here we've got over 8 gigabytes of VRAM on the 7700 XT being allocated, and then when we pop over back to the 8 gigabyte card, right, we're seeing this 12% performance gap. Let's see what happens when we go down to the high settings. When we go down to the high settings, we can now see that the 4060 and the 7600 are within 1 frame per second of each other, 2% performance gap here. And so, and if we go back to the cards that, again, have more than 8 gigabytes of VRAM, when we go down to 1440p high settings, notice that even the AMD card with 12 gigabytes of VRAM is not trying to use more than 8. And again, it is still reporting more than the Nvidia GPUs, though. So this is interesting in that, again, this seems to be confirming the same thing, but in a different game, right, that I was seeing in Talos Principle 2. Let's go ahead and say, so it looks like even with upscaling, the 4060 was showing a larger than maybe expected performance advantage here at that 21% at 1440p Ultra with DLSS. If we go ahead and pop over to our GPUs in the that had more than 8 gigabytes of VRAM here, we are seeing that the AMD GPU at these settings was trying to allocate more than 8, right? Whereas the Nvidia GPUs weren't. So it's not, again, even the 16 gigabyte card from Nvidia was trying to stay under 8. So again, it just seems to be that there is a difference in their efficiency of how they're using that VRAM, which I find interesting. So again, 1080p high settings, the 4060 and the 7600 are performing identically here. And so if we go down to 1440p high settings in the GPUs that have more than 8, notice that even the AMD GPU here is at high settings 1440p staying under 8 gigabytes of VRAM, even though it is still reporting higher than the Nvidia GPUs. So interesting stuff. If we continue to scroll through here, it's interesting because in Lords of the Fallen, while the 4060 has an advantage, it's kind of a consistent advantage regardless of the settings. Here we're seeing it's winning by about 13%. And then as we scroll to other settings, dropping down to high settings, 15%, 18% when using DLSS. I think it gains a little bit of an advantage because the lower internal resolution scales well on its low memory bandwidth. But again, 14% at 1080p Ultra, 15% when you kick on DLSS. The point is that in Lords of the Fallen, the performance numbers don't seem to vary dramatically. They stay fairly consistent around that, mid-teens percentage range. And if we look at the VRAM usage in Lords of the Fallen on our GPUs that have more than 8 gigabytes of VRAM, again, it's basically going to be you'll never see it going over 8. Right, so even at 1440p high, 1440p Ultra, we're still under 8. Always under 8. At all of the settings tested there in Lords of the Fallen, we're always under 8. And when that's the case, even on the AMD GPU report, we're seeing the 4060 and the 7600 keep a much more consistent performance gap between the two. Okay, another game we test, Immortals of Avium. This one does seem to report large VRAM amounts on the GPUs that have it. So let's go ahead and take a look here. Where's our Immortals of Avium testing? I think I did it after RoboCop in this video. So Immortals of Avium 1440p Ultra, you can see the AMD GPU that has 12 gigabytes VRAM is trying to allocate 9.5. Whereas the 4060 Ti 16 gigabyte is trying to use more than 8 here at 1440p Ultra. So in this case, both GPUs seem to be going over the VRAM buffer, at least in terms of allocation. On the ones that have it, if we drop down to these 8 gigabyte cards like the 4060 and the 7600, we see the 4060 with a 9% advantage in this case. Kicking down to 1080p ultra settings, we see the Nvidia GPU with a 8% advantage, and in 1080p ultra here, we once again do see cards that have more than 8 gigabytes trying to allocate more than 8. And I'm bringing this up because Immortals of Avium tends to actually be a more AMD favored title. So I was somewhat surprised to see the 4060 actually beating the 7600 here. I didn't expect that based on my other testing I've done, where AMD seems to generally overperform here. It seems to be optimized well for them, but it seems like that VRAM amount is possibly holding it back there. Anyway, in Jusant, we tend to see a pretty consistent performance gap where the GPUs, the 4060 and the 7600, are basically tied most of the time. Sometimes it can be a 10% advantage AMD there at certain settings, sometimes more like 5%, oftentimes tied. We can see a 4% for the 4060, but the performance gaps are fairly consistent here. They're fairly close. And then in our GPUs, again, that have more than 8 gigabytes of VRAM when we're measuring Jusant, if you just kind of look at the VRAM lines up here, even on the AMD side of things, we generally just don't see it going over 8 gigabytes at all. So again, we're seeming to see the 4060 and the 7600 perform more consistently together when neither one is running into VRAM buffer issues. So anyway, what do we make of this? I do have one more game tested. Because again, this is really coming out of all my Unreal Engine 5 testing, but if we look at Remnant 2 at 1440p Ultra, here we see the 7600 with an 8% performance lead. So this is one where AMD is doing well, so 8% performance lead. And then at the high settings, still an 8% performance lead. So not seeming to be seeing a difference there because of any VRAM issues. With DLSS, the 4060 kind of catches up, but again, I think as you lower the internal rendering resolution, it scales well with its lower memory bandwidth. So I think it catches back up. So that's explainable that way. At 1080p Ultra, 7600 back to a 9% lead. 1080p high, 9% lead. So again, it doesn't seem like we're seeing those wild swings like we saw in some of the other games. And then if we look at our GPUs that have more VRAM, what are they doing in Remnant 2? Well, in Remnant 2, again, if you look up here at this memory line, even on the AMD side of things, at 1440p Ultra, we are under 8 gigabytes of allocation. And as we continue to scroll through, it never shows more than 8 gigabytes of allocation. So what do I make of all of this? So it certainly seems to be the case that AMD GPUs will try to allocate more VRAM. For what reason? And is there possibly any interaction with smart access memory or ResizeBAR here? That was not something I tested out in this video. So I have some question marks there about why, but it certainly seems to be the case that AMD GPUs do report more VRAM allocation and per process usage. And it does seem to be the case that when you look at performance testing between two 8 gigabyte cards, it does seem to be consistent with the hypothesis that the 7600 could be spilling over its 8 gigabyte VRAM capacity in places where the 4060 doesn't, or is less impacted by it, or something like that. Again, explaining that initial result I saw with the 30% performance lead for the 4060 at the 1440p Ultra settings, and then that lead dropping to 8% at the high settings here. Again, that seemed to be consistently supported throughout the video. So I'm interested what you guys think about all of this. I don't want us to run way too far with this. This is one set of tests that I think is hardly a definitive answer to any of this. And like I said, there's other things that could be tested. This wasn't really what I set out to do with this testing. It's just an interesting result I noticed while doing the testing that I wasn't expecting. When you see an unusual result like this, like the 31% advantage, you're generally wondering, okay, did I do something wrong in my testing, or does something explain these results, right? Was this a testing error or is it explainable? And like I said, when I noticed that the gap closed at high settings, and then I went back and looked at my other testing in this game, that's what kind of led me to that, what we're seeing in this video. I'm curious what you guys make of it. I'm also curious if, you know, what further testing could reveal if there was more time, like I said, especially if having maybe ResizeBAR turned on or off makes any difference either. Just curious. Anyway, I think that's it for today. I hope you guys found the video useful and or interesting. A huge thank you to channel subscribers and channel members for clicking the join button, and I hope all of you have an excellent day.